Hello, this is Dr. Daystorms, and I wanted to do a detailed example of the mitochondrial DNA pedigree chart using my own family. You are required to do this for your maternal side of your family since all of your mitochondrial DNA comes from your mother. So let's look at, first of all, where do I fall at on this this pedigree? I'm going to circle or put a square around me. So therefore, this is my mother, this is my brother, and this is my grandmother, my mom's mom. So first off, my mom's mom, my grandmother, had 8 children. She had my Aunt Glinda, Gail, my mother, my Aunt Cindy, my Aunt Juanita, my Aunt Charlotte, my one and only Uncle Paul, and then my Aunt Tracy. I have also included some of the biological children for space reasons of each of my aunts and my uncles. And so you can see my Aunt Glinda here has 4 daughters. My Aunt Gail has 1 daughter and 1 son, and so on and so forth. And my Aunt Tracy had 5 children, 3 boys and 2 girls. Okay, so the goal of this is to show you everyone in my maternal family that shares the same mitochondrial DNA that I have. So I'm going to choose a different color now. Let's see. I will use this color. All right, so first off, of course, this is me, and my biological brother is going to have the same mitochondrial DNA. We inherited this DNA from my mother, who inherited the DNA from my grandmother. Now please note, my grandma here, she's going to pass on her mitochondrial DNA to all children, whether they're male or female. So that means my Aunt Glinda, my Aunt Gail, my Aunt Cindy, my Aunt Juanita, my Aunt Charlotte, my Uncle Paul, and my Aunt Tracy all have the same mitochondrial DNA as I do. Now, let's look at my Aunt Glinda here as the example. She's going to pass off the mitochondrial DNA to all of her children as well. For my next aunt, she's also going to pass off the mitochondrial DNA to all of her children, regardless of whether they are male or female. So each of my aunts will pass off mitochondrial DNA to their children. Now, what does this mean? I'm going to highlight something here. Please note, I'll do it in this color right here. The only person who doesn't, in this group of my cousins, the only 2 people are my 2 cousins here. They would have inherited their mitochondrial DNA from their mother, who is not my biological relative. So therefore, of all my cousins, they are the only ones that do not share the same DNA as I do. Another example of this, and I won't do this for all of my cousins just because of the fact that it would get quite lengthy, but let's look at a couple of examples. So, for example, my cousin Jamie here, she has gone on to have 2 children of her own. Likewise, her brother Jason, my cousin Jason, he's gone on to have children as well. Okay, so let me draw in their children. Girl. Like I said, almost all of my cousins now have children of their own. However, now let's look to see which one of these cousins would also have the same mitochondrial DNA. So if we look up here, since my cousin Jamie is a female, She will also pass on the mitochondrial DNA to both of her children. However, my cousin Jason is a male, so I do not share the mitochondrial DNA with his children because they would have inherited the DNA from their mother. So just in this brief tutorial here, you can see where if we go back to where I am, I share the mitochondrial DNA as the same as many, many people. However, my nuclear DNA is different. Remember, nuclear DNA is unique. Mitochondrial DNA is a class characteristic. So this one is a class characteristic, whereas the nuclear DNA is a unique characteristic, or it's an individual characteristic. So many times you can use mitochondrial DNA to help exclude people, but not necessarily prove that a specific person is the perpetrator of a crime. Hopefully this has helped you in determining how you need to set up your mitochondrial DNA chart for class.